Assalamualaikum and hello everyone. Welcome to our presentation for BMKU 4743 Renewable Energy System. In this video, we will be presenting about biomass energy in Sabah and Sarawak. First, let me introduce our group members. The first one is Anishano, which is me. Next is Muhammad Izdihar Faik, Lilin Anak Alam, Wan Anura Beta Adawiyah, and lastly, Arshini. Now, let's move to the introduction. Biomass is a renewable energy source produced from organic materials such as agricultural waste, wood waste, and palm oil residues. Sabah and Sarawak have very high potential for biomass energy because both states have large palm oil and forestry industries. Some common biomass materials include empty fruit bunches or EFB, palm kernel shells, palm oil mill effluent or POME, and also wood and forest residues. These biomass materials can be converted into useful energy such as electricity, heat, and biofuel.
The energy landscape and framework. The energy framework in East Malaysia is decentralized, allowing for state-specific strategic roadmaps. For Sarawak framework, driven by SCORE, and the hydrogen economy roadmap, focus on POME to biogas. For Sabah framework, guided by Sabah Energy RAMP 2040, managed by Energy Commission of Sabah.
Biomass Trend Sabah and Sarawak 2026. By 2026, biomass is projected to transition from a waste disposal by product to high-value industry feedstock under the 13 Malaysian Plan. There are three important. For the first one is a biorecreation hub. This emergency for detected biomass cluster in Betul and Sadakan. For the second one is co-filling interactivity. Increase benefit for core power plant to integrate biomass pellet. For the third one is export expansion. This is growing demand for palm oil biomass pellet in East Asian market.
Next is the evaluation of Malaysia's energy policy related to renewable energy and biomass development. First is the National Energy Policy or DDN introduced in 2022. This policy established the main blueprint for long-term carbon reduction across industrial sectors in Malaysia. It also encouraged the development of cleaner and more sustainable energy sources. In 2023, the government launched the National Energy Transition Roadmap, also known as NETR. This roadmap officially introduced clear renewable energy targets and strengthened Malaysia's commitment toward energy transition. In 2024, there was a regulatory shift in Sabah, where power and energy regulatory authorities were transferred directly to the Sabah state government through ECOS, or the Energy Commission of Sabah. This allowed more localized and efficient energy management in Sabah. Finally, under the 13th Malaysia Plan in 2036, biomass is expected to become a more important mainstream energy source. The government plans to integrate high-value biorefinery incentives, which will help transform biomass from agricultural waste into valuable renewable energy products. Overall, this policy shows that Malaysia is moving toward a greener and more sustainable energy future.
Key issue in East Malaysia. There are several issues in East Malaysia, especially in Sabah and Sarawak. For the first one is high logistic costs. Biomass resources are vastly dispersed in rural and plantation area, the increasing transportation costs. For the second one is supply inconsistency. Biomass availability depends on seasonality, agriculture, production, especially palm oil waste. For the third one is limited infrastructure. Lack of advantage biomass processing plant in Sabah and Sarawak, slowly and large-scale environment. For the fourth one is high intelligent investment. Biomass power plant require a expensive technology and setup costs. For the fifth one is environment and handling issue. Improper handling of waste like polymer can still causing pollution if not proper treated. For the last one, technical expressly limitation. Shortly of the skilled workforce in biomass, energy, technology and operation. The picture shows is Sabah Sarawak palm oil biomass wasted issue dump.
There are several challenges in biomass development Sabah and Sarawak. Firstly, Logistical barriers. Biomass sources like palm residues are scattered and far from power plants, increasing transport costs and reducing efficiency. The second one is infrastructure limitations. Limited grid connectivity in rural Sabah and Sarawak makes it difficult to integrate biomass in power into the national grid. The third one, technology gaps. Many mills lack advanced conversion technology, leading to low energy recovery. The fourth one is policy and investment constraint. Inconsistent incentive and slow approval processes discourage private investment. Lastly, environmental and sustainability issues. Poor waste management and land use conflicts can undermine sustainability goals.
Now, let's discuss the advantage and disadvantage of biomass energy. For advantage, first, renewable energy source. Biomass is continuously available from agriculture and forestry waste, making it a sustainable option. Second, abundant resource. In Malaysia, particularly Sabah Sarawak, there are large amount of palm oil and timber waste that can be converted into energy. Third is waste reduction. Biomass can convert palm oil residue, wood waste and other organic waste into useful energy to reducing landfill waste. Fourth, reduce greenhouse gas emissions. Using biomass produce a lower carbon footprint compared to fossil fuel when managed properly. Fifth, support rural economy. Biomass project create jobs in waste collections, processing and also energy production to benefiting local communities. Last is energy security. Biomass reduce depends on imported fossil fuel, strengthening national energy resilience. For disadvantage, it has high transportation costs. Biomass is bulky and scattered, so transport is from plantations can be expensive. Second, inconsistent supply. Seasonal production affect continuous energy generation. Third is high initial investment. Biomass power plants require significant capital for infrastructure. Fourth, lower energy efficiency. Conversion efficiency is lower compared to conventional fossil fuel plant. Fifth, environmental risk. Improper handling of waste such as BOME can cause water pollution. And lastly, technology limitations. Advanced system and skilled operator are needed, which are still limited in Malaysia. For overall, while biomass has strong environmental and economic benefit challenge, remain in cost, efficiency and also technology availability.
Now let's look at the overall biomass statistic for Malaysia focusing on Sabah and Sarawak. In Sarawak, the installed capacity reached 4,437 MW with a peak demand of 3,350 MW, giving a reserve margin about 34%. Sabah, on the other hand, has an installed capacity of 1,567 MW and a peak demand of 944.9 MW, maintaining a slightly higher reserve margin of 37.9%. Across Malaysia, the total biomass potential at 3.6 GW broken down into 2.3 GW biomass, 726 MW biogas, and 516 MW solid waste. Palm biomass contribute more than 80 million tonnes per year, while rice hash ash at around 30 million tonnes globally. These figures show that East Malaysia play major roles in the country's renewable energy potential, with strong capacity and abundant biomass resource ready for sustainable development. Next, let's focus on the fact and figure for Sabah and Sarawak. Sarawak lead with higher installed capacity and peak demand, reflecting its stronger energy infrastructure. Sabah, although smaller in capacity, maintain higher reserve margin, meaning it has more flexibility to meet future demand. Both states contribute significantly to Malaysia's biomass footprint, especially through palm oil residue and agriculture waste. Together, they represent more than 80 million tonnes of biomass annually, forming the backbone of Malaysian bioenergy supply. By comparing these two regions, we can see Sabah and Sarawak complement each other, Sarawak providing capacity strength and Sabah offering expansion potential for future biomass projects.
Next, let's review the progress of biomass energy in Malaysia from the past to the future. Previous 2001 until 2005, small biomass project under the SERP initiative, mostly focused on palm oil mills. Current 2011 until 2017, feed-in tariff program, now replaced by net energy metering and large-scale solar. Biomass energy is still underutilized quite available resource. For the future, target by 2025, my RER aim to achieve 3.6 gigawatt of bioenergy, focus on leveraging resources like palm oil, rice hulls, and municipal solid waste to meet target. This shows a steady progression from small-scale experiment to planned large-scale utilizations, highlighting opportunities for Malaysia to expand its biomass energy capacity in the near future.
The conclusion for this is biomass energy in Sabah and Sarawak is a promising renewable energy source due to the abundant availability of agricultural and forestry residues, especially from the palm oil and timber industry. However, its development is still limited by challenges such as high transportation costs, inconsistent biomass supply, significant initial investment, lower conversion efficiency, environmental concern from improper waste management. Overall, biomass energy remains a sustainable option for Malaysia, but improvement in the infrastructure, technology, and supply chain systems are essential to fully realize its potential. To conclude, these are the key references that supported our research. That's all from our group. Thank you.